Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about Riemann integration. I will cover all those questions from the CSIR NET as well as the GATE mathematics of these years. Myself Dr. Harish, you can simply follow my YouTube channel where there is a playlist of the CSIR NET, GATE and the IIT JAM. Here you can see the PY question on the topic wise as well as the subject wise is available in my this playlist. You can simply follow it and learn various shortcut tricks for the problems. What is the objective is? The objective is we will cover all those Riemann integration problems. I will cover the 45 plus question in this lecture from the part B and part C with the help of the shortcut trick. Firstly, I can quickly go through what is the shortcut tricks for you and how you can approach towards the Riemann integration. Whenever you want to prove a function is said to be the Riemann integrable if either of the following properties satisfied. First one, if a function is a continuous, like if I say sine of x, then clearly says it's a continuous function, so it is a Riemann integrable. If it is a monotonic function, it's a monotonic. It may be increasing or decreasing. So if it is increasing or decreasing, then it's called as a monotonic. So if the function is monotonic, we can say it's a Riemann integrable. Make sure the function should be defined on the closed interval a comma b. Remember, on the closed interval. Next one is if the function is not monotonic, that means, or if the function is not continuous, then what kind of the continuities are there? If the function is not continuous, what is the meaning of that? This function is discontinuous. So if it is a discontinuous, what kind of the discontinuities they have? If it has the finite discontinuities, then again you have a function is Riemann integrable. If you have a discontinuities which is a countable point plus a function is bounded, make sure a function is bounded. If I say a function is bounded alone, then it doesn't mean that it is Riemann integrable. But if the function is bounded plus something, that is if the function is discontinuous at the countable points, then you can say it's a Riemann integrable. Moreover, if you prove that the function is bounded and the limit point of the discontinuous is my finite, then again you can say it's a Riemann integrable. And the last point is if you prove that it's a function of the bounded variation, then again you can say it's a Riemann integrable. We will see this, how you can prove the function is the Riemann integrable, that we will see in our next lecture. Now, based on all these points, make sure the converse need not be true. It means if I say the function is Riemann integrable, it doesn't mean the function is continuous. It doesn't mean a function is monotonic. It doesn't mean it has a finite discontinuity. Make sure if the function is not bounded, fine, it implies the function is not Riemann integrable. Fine. Another one is if you prove that the function is said to be the Riemann integrable if and only if, that is if and only if the measure m is my measure set of, if the measure of the set of the discontinuity is my 0, then you can say it's a Riemann integrable. The sum of the two Riemann integrable function is a Riemann integrable function where alpha and beta are the any of the reals, and the composition is also the Riemann integrable if you prove that f is my Riemann and g is my continuous. Then you can say it is a Riemann integrable, otherwise not. Now based on these small shortcut tips for you, I can solve all those 45 plus questions within a couple of seconds, and you can also solve with me after learning. So let's start with this one. So firstly, a function is given to you on the closed interval 0, 1 to r is integrable, not n here. First of all, you can see that this is always a -1 or +1. It means when r is my odd and when r is my even. What does it mean? It means the function is my bounded. Fine. So if the function is bounded, he said unbounded is a cancel out. Now, if the function is bounded, you need something more. What is the something is? You have to find the discontinuities, whether it's a countable or whether it's a finite or infinite are there. How you can prove that? Very simple. You can clearly say this function has discontinuity at this point. It's also discontinuity at this point. Okay, so you can see the function is discontinuity at 1 by r. It's also the discontinuity at 1 by r, and so on. Or you can simply say, I can simply take r is my 1. Then what will happen? This function is a plus 1. It's a half less than x less than 1. If I take r is 2, then it is minus 1. It is 1 over 3 x 1 over 2 and so on. So clearly says the function is discontinuity at half, function is discontinuity at 1 by 3 and so on. So what does it mean? It means the function, what is the set of the discontinuities? What is the set of the discontinuity is nothing but 1 over r, where r is 1, 2 and so on. Also you can see the function is discontinuity at 0 also, because 0 is there, but what about the 0 positive is my here. The function is discontinuity at 1. Now look at that. I need whether it's a countable or the limit point. So whenever here, can you find the limit point of this? What is the limit point of this? Is a 0 as r approaches, which is my finite. Fine. So now the limit point is finite, it is a bounded, it means this is my Riemann integrable is the right answer. So I use this shortcut tricks, bounded plus limit point is finite. This is the first example. Based on the same trick, I can solve the many of the example in this lecture. So now you can see many more. Look at this one. Which of the following is a Riemann integrable? Check whether it's a continuous function. So clearly says this is my discontinuous function. At which point? If this is a discontinuous, we will see whether they are the finite point of discontinuity or infinite points. Fine. Now clearly says this function is discontinuity for all x in the real, and we know r is my uncountable. So once it's uncountable, it means this is my not Riemann integrable. If it is a countable, then you can say it's a Riemann integrable. Second part is, if f of x is my here, clearly say it's a 1 and 0, it is bounded, it is also the bounded. Fine. And if x belongs to the AIs are my fixed but chosen arbitrary. What is this means? Also AIs are my discontinuous points, but which is my finite. Fine. So if it's a discontinuous which is a finite, what does it means? It is my Riemann integrable. Look at the third point. X is irrational 0 or x is 0 and p by q. So clearly says, is the function is bounded? Is the function is bounded? It is not bounded. So if the function is not bounded, it means it is not Riemann integrable. So this option is also cancelled. Correct option is my B is the right answer. Okay, look at this another one. Again, you can see the function is given to you 1 over 2n and 0 whenever x lies between this to this. So clearly says this function is my bounded. Fine. Now what are the set of the discontinuity? What is the set of the discontinuity? 1 over 2n. This point is also set of the discontinuity and so on. Or I can say this is in general, it is my here when n is my 0, 1 and so on. Why? You can simply say if I take n is my 0, what will happen? It is 1, it is 2 less than 1. Fine. When I take n is my 1, it is half, it is my 1 over 4 less than x less than of. So clearly says the function is discontinuity at 1 at half. Similarly, the function is discontinuity at 1 by 4. Now this is a set. Can you find the limit point? Limit point is 0 as n approaches, which is my finite. So the limit point is finite and it is a bounded. What does it mean? F is my Riemann integrable. So now you can see about that. They are not talking about so they have the infinite number of the discontinuity. Yes, they are infinite. We have infinite limit point, but we have a finite limit point. It's a finite number of the discontinuity, but we have an infinite number of discontinuity. Infinite number of discontinuity with the finite limit point is a correct option. Finite number of the discontinuity is a cancel. So also this implies f is my Riemann integrable. Look at this another one. F is a Riemann integrable such that this is there. Again, first of all, we all know if f is my Riemann integrable, okay, you can see the function which is dependent on the x, it is my constant because it is independent of the x. Every constant function is a continuous function, so it means this is my Riemann integral. Fine. Then how you can integrate them? Oh, very simple. You can simply say I can return this function as this function into length of the domain. What is the length of this? So function will be my 2 raised to power k minus 1 over 2 raised to power k. What is the length? You can see I can subtract them. What I can see 1 minus 1 over 2k minus 1 over 2k. This is my length of the domain. So what is that? 1 will be cancelled out. 1 over 2 raised to power k common plus of 2. It is 1 over 2 raised to power k. Is it fine? 1 over 2 raised to power k common. It is a minus 1 and it is a 2. So yes, it is a domain is my here. So now can you find the sum of this? It will be, if I open this, it is my here minus it is 1 over 4 power k, where k varies from, what is that? K start from the 1 to infinity. Fine. Now what is that? It's a GP. The sum of this is first term over here is a GP 1 over 3 by 4. Now what is the right answer? 1. It is 1 ratio is 1 by 4, so it's a 1 over 3. So it is my 2 over 3. So the right answer is A. Rest all options are cancelled. So the correct answer is A is my right answer. Okay, f is my continuously differentiable function. Now f is my continuous function. If f is continuous, it means f is my Riemann integrable. U and L are my upper and the lower bounds, and then so on. I think is again a very simple. What is the definition of the Riemann upper sum and the lower sum? Fine. I can return this number as capital Mi, small mi, and change in the length. Fine. I varies from 1 to, if the partition is my n number of the partition. Now look at that. We all are needed up to the k. Where is the k? Is here. Fine. Okay, and we need, first of all, the change in length is not given to you. Okay, we all knows what is the change in length. We all know is less than. This is always be less than of the norm of partition. So I can return this number is less than of p of this one. Fine, where m is my upper bound and small m is the lower bound p. So I can also return, if I open this bracket, what is that? It's a function value and of this value, it will be less than of this. Fine. Now look at that. Now I need to remove this one, so I can use this definition. This is less than of the k and it's a continuous differentiable, so I can apply the Lagrange mean value theorem. What is the Lagrange mean value theorem? Fb minus fa over b minus a is less than k. So what is the value of this? Norm of p, k times b minus a. What is that? Norm of p, k, b minus a, k, but what is the b minus a? B and a, it is not always 1. It is, no, it is norm of p is must be there. It is also cancelled. Right answer is only D is the correct option. Okay, f, g and h are my bounded functions on the closed interval such that f is less than g is less than h. P is the any partition, u and l are lower, upper and the lower, and then so on. Okay, fine. What does it means? If I apply the upper partition, g is of this, fine, and if I found the lower, it is also be here, fine. Now look at that, what is your target? If this condition, okay, our target is to find this one, UG, LG, U and L. Okay, so what is the U of G minus L of G? It is less than or equal to, you can see U is less than of H comma P. Because of this negative, I have to take this part, so it is a minus L of F comma G. Now in order to prove this one, UH minus UF, UH minus UF, it is not UH minus UF, that's wrong, because we need a U and L. This option is cancelled. L and L, it's again a cancel. UH and LF, if this is less than 1, then this is also less than 1, is the correct option. L and U, LH minus U of F. Fine. When it will be happen, it is only happen if you start from here, minus U of G. Fine. This becomes my here. Fine. It will be less than or equal to this, but we need a U is the first one. Here is the L. So this number is less than 1, but we need a here. So this option is also cancelled. C is my correct option. Okay. F is my differentiable function. If F is differentiable, it means it's a continuous. If it is a continuous, it means F is my Riemann integrable, such that F dash is my bounded. Consider closed interval, this lower sum and upper sum and here. Okay, you can choose any of the interval a comma b. First of all, I can simply choose 0 and say 7. Fine. What is the infimum of F over this domain? Infimum will definitely be 0. Fine. If infimum will be 0, this value will be 0. So it means this modulus value will be less than 0, which is not true. What is that? If this value will be less than 0, it only happens when this value are equality. It is not always true that upper bound, sorry, M, capital M is a lower, is always equal to this one. Similarly, this infimum is also cancelled. Now look at the supremum. How you can say the supremum is less than of this? I think again a very simple. I can apply the definition of this integration of f dx. It must be less than of UPF. It must be less than of the LPF. Also, it must be less than of the supremum of range. It must be greater than of infimum of range. Fine. Where S I called as the supremum, I is called as my infimum. Fine. U and L are my lower and upper sum. So here lower is my M, sorry, upper is my M, and small L is my basically M is given to you. Now I can start from the first one. Capital M minus of this. So what will happen? This value will be less than of S of B minus A minus of F dx. Fine. Now this number is always less than of this. Fine, because this number is my positive. Now what is the S is? Supremum. So you can see B minus A supremum of S is the correct option. He said square, wrong option. If I want to prove this, small m minus of this, small m minus of this, it will be less than of S minus A minus of this, which is again less than of this number, that's a supremum, but he said infimum. So this option cancelled. Right option is my A is the correct option. Look at this another one. What is given to you? A function is a monotonically increasing from this. If f is monotonic function, what does it mean? Look at the option continuous, continuous, Riemann. Okay. If f is my monotonic function, what does it means? It is Riemann integrable. Fine. And if f is Riemann integrable, it always implies the Lebesgue integrable. Fine. Remember, always Riemann integrable implies Lebesgue integrable. but converse is not true. Fine. So these two options are there. Now continuous. What is given to you? F is monotonically increasing function. So what is that? If it's a monotonic increasing function, then either it's a continuous or it may have discontinuous function. If it is a continuous function, then we can say it's the Riemann integrable. But what kind of the continuity is there? Is there any? If it is a continuous, firstly, if it's a discontinuous, then we all know it has a jump discontinuity. Fine. The only function which is a monotonic increasing is the jump discontinuous function. If it is a jump discontinuous function, what is the meaning of that? It has countably many breaking points or countably many points in the domain. Fine. So what does it mean? F must be the continuous at all, fine, but finitely many points is the wrong option. F must be the continuous, fine, apart from the jump discontinuity. So what is the coordinate of the jump discontinuity? Countably many point of this. So the right answers are B, C and D are my correct answer of this problem. Look at this another one. Okay, a function is Riemann and so on. Okay, very simple. You can see a function f is continuous at, you can see what is the meaning of the continuous is the left hand limit and the right hand limit must be same. So when it will be same? Only when x is 0. Okay, so it means the function is continuous only at the point x is equal to 0. What does that means? Can you say it is a how you can say if the function is continuous only at this? What is the meaning of that? How many discontinuity points are there? Discontinuity points are there r minus 0. Fine. If r minus 0 is my discontinuity points, then what can you say? What can you say about discontinuities? Okay, if it means, but r is my uncountable. Fine. So what does it mean? F is not Riemann integrable. So f is not Riemann integrable is the correct option. This is cancelled. This is cancelled. Now once f is not Riemann integrable, it means the lower Riemann sum is not equal to the upper Riemann sum. Then how you can find that? What is the lower is? If I call this is my L, this is my upper. Now look at that. On the domain 0, 1, take any point inside it, say point 1 by 3. Fine. Look at that, x square and x cube. Which one is a minimum? It's a 1 over 9. It is 1 over 27. Fine. So clearly says this value will be my minimum. This value will be my maximum. So this is the corresponding to the u. So what is the integration of this over the domain? It is my 1 over 3. That is my upper sum. What is the lower sum is? You can integrate this over the 0, 1. It is 1 over 4. So it means the lower sum will be my, you can see it's a lower sum is 1 by 4. Upper sum is 1 by 3 is the right answer of this problem. Okay, you can scan and join my WhatsApp group if you want. So till then we can solve many more still now. Okay, let eta be the function which is 1. Okay, this is nothing but the indicator function. Fine. So what is the function of the fx is? It is summation n very strong 1 to 200 1 over this. If x, that means if this function belongs to this. Okay, fine. It's a Riemann, it's a Lebesgue, it's a continuous, it's a monotonic function. Now clearly says this function is my monotonic. Fine, because either the function is increasing as a value of the n is 1, 2 and so on, is a monotonically increasing or monotonically decreasing. If f is my monotonic, fine. If f is my monotonic on the closed interval, so it means f is my Riemann integrable. So this option is also correct. If f is my Riemann integrable, it means it is also called as the Lebesgue integrable. Now the question arises is whether it's a continuous or not. Clearly says this function over this. Okay, so what is that? This function is my discontinuous. At which point? at every point of n over 200. Fine, because function is continuous at 0, because this value said if it is a 0, what is this? It means it is a value of this whenever x lies here, otherwise 0. So if I say 0 comma n over 200, so clearly says function is continuous at 0, but the function is continuous at every n where n is 1, 2 up to 199. So it means the function is discontinuous, but he said continuous function. Moreover, if the one ways you can prove is a monotonic, then it's a Riemann, but you can see they are my countable points. So once it's a countable, this is the bounded function, so it's a Riemann integrable as well. But there is no need, if it's a monotonic, it's a Riemann integrable. Okay, look at this another one. How you can prove that function is strictly increasing, g is given to be here, partition Riemann. Okay, which of the following condition is here? Okay, this condition already hold, because we all know upper sum is always be greater than of the lower, so this result is cancelled. Now look at the first and second option. The first option said equality, because it's a greater than or equal to. Remember, if I say the function this, when the equality will be hold, equality will be hold only if this function g is my constant. Fine. Now is the function g is constant? What is the g is? F plus f of 1 by x. This is given to you. What is the statement said? For a suitable f, can you choose a function f? Can you choose a function f over this domain? This implies g of x is my constant. If we are able to choose, then we can say this option is correct. Now look at that. G is my fx plus f of 1 by x. A very simple example, I can choose a function is my x. Fine. Over the domain of this. What is a g of x? G of x is x, which is not a constant. But if I choose my function is x into 1 by x into x minus 1 by x, then this value will be my 0, and 0 is my constant function. Fine. So it means for a suitable f, yes, this value clearly lies between half and 2. Fine. So for this particular f, we can say the function g is a constant, so there is no need to find the UPF and the LPF, because if I prove g is a constant, then it is result is whole is the correct option. Look at this second option, whether the second option is correct or not. It's not equal to, so you have to prove the counter example. So I can simply take the partition of half and 2 and take any number in between them. So you can see it's a 2.5, I can say 1.5. Fine. Then can you find the lower for any suitable f, and I can choose the function f is here. Fine. The what is the LPF is function is x, first point is interval is half. Okay, here is a g. So what is my g is x plus 1 over x. Fine. So it will be my g of first point is, what is the, no, is it correct? No, sorry, I need a function on the g. What is the domain of the g is 1 comma 2. So instead of this, I need to take the partition as 1 2 and take the midpoint of this 3 by 2. Fine. Then what is the LPF is function value at the point into the difference. What is the difference is half plus function value at point and some difference. What is the difference is 2 minus 3 by 2 is again 1 by 2. Now this is the value of LPF. What is the value of this is lower limit 1 up and second is 3 by 2. What is the U? Here is a G. So for the upper we have to take these two values. So G of 3 by 2, what is the difference is half. G of upper difference is half. Then they are not equal, I can simply take u minus L. So this value will be cancelled out. U minus L is a g of 2 minus g of 1. Half will be common. So clearly says g2 and g1 are not same. g2 will be my here and g1 will be over this. So it's a 5 over 2 and it's a 2. Clearly says this number is my non-zero. If this is a non-zero, it means they are not equal. So this is the correct option. So A, B and C are my correct answers. Look at this another one. Consider a function f is my identity function on the interval 0, 1. P is the partition is divided into the n equal parts. I can divide it equally, n minus 1 and 1. Fine. U and okay, very simple. Can you find the lower limit? Okay, you can see what is the step size is. Step size is here. Now which is a constant throughout. Fine. Then you can easily do the step size. If one is a constant, you can take it as a constant into summation of the, because it's upper, you can start from here to this. So I can return this number as 1 over n, 2 over n and up to last is 1. And how you, what is L? 1 and take the first n numbers 0, 1 over n up to n minus 1 over n. Now I can return this number is n over n. This is here. What is that? It's a sum of AP. So what is that? It is a n plus 1 over 2 into n. Fine. I can take n as a common. So again the numerator part is my n minus 1 over 2. Then you can define the a n. U minus L. So 1 by n square is common. 1 by 2 n square is my common. So what is that? N square plus n minus n square minus minus plus n. So 2 will be cancelled out. An will be my 1 over n. Fine. Now you can see what is the limit of this. It's a 1, but he said cancel. Series. What is the series of? Is a divergent by P test. This is cancel. It's a monotonic decreasing. You can see what is the derivative of this. Minus 1 over n square, which is less than 0. It's a decreasing. Correct option. Summation of this I can write here. An is my 1, so it is 1 over n plus 1. So what is that? This is nothing but telescopic series. I can return this as partial fraction. Fine. Now if I start from the 1 to infinity, so what is that? It's a 1, 1 over 2, then 1 over 2, 1 over 3, 1 over 3, 1 over 4 and so on. So clearly say this will be cancelled, this will be, and the last term is when n approaches infinity, you can see the last term will be n plus 1. So take limit n approaches infinity, 1 minus 0, 1 is the right answer. So the correct answers are C and D are my correct answers. Okay, look at this another one. A function f is given to be here, whether it's upper and okay, fine. Clearly says the function is my bounded. Fine. So it means we need to prove a function is discontinuous as a countable. Fine. What is that? Firstly, f is my discontinuous function for what value of the x? 4. Is a rational, is a discontinuous for all these values of the r, and we know r is my uncountable. So what does it means? F is my, although it's a bounded, but it is a uncountable. So f is not Riemann integrable. This is the right answer. Always remember my simple tips as I gave you in the earlier. Okay, look at this another one. Again you can see the function is bounded. Fine. So you need to prove whether it's a continuous or whether it's a discontinuous countably or not. You can see function is discontinuous for all the rationals. Function is discontinuous for all the irrational. It means the function is discontinuous for all x in the real. So what is, again it's uncountable, so this is my f is not Riemann integrable. F is a Riemann integrable, cancel is here. F is continuous only at the irrational, is a cancel, continuous everywhere, cancel. C is my correct answer. Look at this another one. F is given to be here, again clearly says the function is not continuous, okay, and function is not continuous for each x is in the R. So what is the meaning of that? F is not Riemann integrable. If f is not Riemann integrable, then the upper sum is not equal to the lower sum. In this case, a is my upper sum, that is a is not equal to b is my lower. So a is not equal to b. So first option cancel, D option cancel. Now, what is the upper and lower? So again a very simple. What is the minimum of this? So 0 will give you the minimum value always. 1/2 is my upper value. So upper is half, 0 is here. What is the domain is? 0 to 2. So what is the answer of this? 0, it is 1. So lower means that is B is my 0, A is my 1. So B is my correct answer of the problem. You can see how many seconds you are needed to think about that. There is a fraction of second are there. I hope you can like my video. Okay, look at this one. Clearly says f is my bounded. Fine. Again clearly says this has discontinuous function for all the x, which is my uncountable. They are uncountably discontinuities. So what is that? It means f is not Riemann integrable. So f is not Riemann integrable, correct. F is integrable, cancel. F is a bounded function, yes, so it is a Riemann integrable, cancel. F is a bounded function, correct. But f is not integrable is also the correct option. So A and D are my correct answer. So again you can see this is the one counter example which said bounded function does not implies is a Riemann integrable. You can see the one counter example here. Okay, f is a function to be here, p and find the un. There is no need to solve the problem. Fine. We all know the lower LPF is always be less than of the UPF. So first number is u. 5/8 is not greater than of 7/8. So this is cancelled. 5/8 is not greater than 9/8. This is not greater than, only left option is D is the correct answer. Fine, that's a very simple. Otherwise you can calculate it because the partition is given to you 3/4 and 1, and you can see the step size is 1/4, which is a constant in the each case. Fine, which is a same. Constant means that is equal as the same. Then how you can find the lower is, I can take 1/4 is outside. I can take the sum of the first 4 numbers. What is that? 4, 6/4. So clearly says it's a 3/2. So 3/8. Lower is my 3/8 is the only one option. How you can find upper is 1/4 constant outside. I can take the upper values are there. Sum of the upper 4. So what is that? I can written this is 4/4. 4 is LCM. It's a 10/4. So it's a 5/2. 5/8. Again is the right answer. But there is no need to solve. We can simply think about, because the lower is always less than of the upper. Okay, look at this another one. Function is Riemann integrable or not. First of all, is it a bounded function? Yes, because cos and sine both are my bounded function. Is a bounded function. Fine. Now, is it a continuous function? So this function is continuous only at x is pi/4, because cos and sine is only existence over the domain 0 to pi/4 is only pi/4. What does it means? What does it mean? F is continuous only at the one point. Correct option. Now can you say what is the discontinuity? So it means it has infinitely many discontinuities. It has infinitely many discontinuities over this domain. But can you think about that? Okay, it has infinitely many discontinuities. So what is that? It means f is not Riemann, because they are uncountably are there over this q intersection of this, they are infinitely are there. So r is uncountable, q is here, so it's a not Riemann integrable. So this option is cancelled. R is not integrable is a correct option. F is a continuous, wrong option, because f is continuous only at one point at of pi by 4, and pi by 4 is here. So C and D are my correct answers. Okay, look at this another one. Clearly say this function is my bounded. Fine. Now if function is bounded, you need to prove as a discontinuities. Clearly says how many discontinuities are there. Function is discontinuities at 1 by 2, 1 by 4 only, because the rest of the values are my here. So what is that? Yes, it's a closed interval, it's a 0 positive and 0 negative. Okay, fine. So what is that? These are my finite. Fine. Discontinuities are my finite, it's also the bounded. What does it mean? F is my Riemann integrable. Fine. If f is my Riemann integrable, if I say also 0, because function is not, is the function, what is the x is 1? Is the function is continuous? Yes, because what is the limit of x 1 minus 0? What is the limit of x positive? Because nothing is, it means else is my 0. So again a 0, and also it's a closed interval, so 1 is there. So function is only discontinuous as 2 point. So it means function is Riemann integrable. Now once the function is Riemann integrable, so we can say the lower and the upper are same. So we have to, domain is my 0 to 1 fx dx. It will be, what is the function of the 0 to 1 is almost everywhere is 0. Integration of the 0 is my 0. So C is my correct option. It is 1 over 4. Cancel. C is the only right answer of this problem. Okay, look at this another one. F, okay, clearly says this is my bounded function. Fine. Yes. This, okay, firstly we can think about the f. F is a bounded function, but this is my discontinuous function for all x. Fine. So if all the x are there, so they are my uncountable. Fine. So if they are uncountable, it means f is my not Riemann integrable. Fine, because it is clearly says the function is not Riemann integrable. So both cancel. F is not, I think here is f. F is Riemann integrable, but G is not. So this option is also cancelled. Now look at the G. The G's remain the same. Again, G is my bounded, and it has a discontinuity function for all the x which is uncountable. So G is also not Riemann integrable. So both are not Riemann integrable is the right answer of the problem. Look at this another one. You have to find the upper and the lower sum. Okay, fine. Okay, on this 0, 1, your target is to check whether this or this, which will give you the maximum and the minimum value, which will give you the minimum and the max. Take any point in between them, say 1 by 2. This value becomes my 1 minus half is half. This value becomes my 3 by 4, means root 3 by 2. This is my 0.5. This is my 0.86 something. So what does that means? This value will give you my upper bound. So I can integrate over this. This will give you my upper value. Lower value will give you my 1 minus x. There is no need to consider the partition of this like 0, 1 over 2 something. There is no need to think about that. So I can solve this integration easier. So it is x minus x square by 2. It is my half. So what is that? Lower is my half. There is only one option is there. So rest options are cancelled. Otherwise you can solve this integration We all know this is x square by 2 plus a square by 2 sine inverse x. So what is the answer of this? When you take x is a 0, x is pi by 2 into 2, 4, 0 is a 0, 0 is 0. So pi by 4 again, a is the right answer of this problem. Let's see the fixed point. A function is given, that function is Riemann. Okay, you can see that a function is bounded. Fine. Function is a discontinued. Fine. Only at x is equal to c. Fine. So which is a finite number of the discontinuity. It means the f is my Riemann integrable. So once the Riemann integration, then this function is given to be here. Now it's a very simple. I can take the options. So look at that. If I take the first option, the function becomes my half and 1, when it will be 0 to 1 by 2 and half to 1. I can check whether the integration is 7 by 6 or not. So what is the integration of this? Half, 0 to 1 by 2, 1. So clearly says 16 will not be appears. So it is 1 over 4 plus 1 over 2. It is not equal to 7 by 16. Cancel. If I take 1 by 4, then it is 1 by 2. Function is my 0 to less than of 1 by 4. 1 by 4 to 1. So what is that? If I integrate of this function over this, it is a 1 over 16. It is my 3 over 4. So 3 over 8. So 8 is LCM. 16 is LCM. So 7 by 16. So third is the right answer of this problem. We can check about this one also. So it is 1 over 3 and 2 over 3. This is my 0 to 1 over 3, 1 over 3 to 1. So 1 over 9, it's a 2 over 3. So 4 over 9, which is not equal to. And the last one is 1 over 5. So 1 over 5 and 2 over 5. This integration from 0 to 1 over 5. And this is 1 over 5 to 1. So it's 1 over 25. It is 8 over 25. It's a 9 over 25, which is not equal to 7 by 16. So C is my right answer. Okay, look at this another one. A function is Riemann or okay, fine. What is the f is 1 over n. If x is my 1 over n is my natural number and 0. Now since n is my natural number, so 1 over n is my bounded. Fine. What does it means? F is my bounded. Fine. Now in order to prove is a Riemann integrable, we have to prove discontinuities. What is the discontinuity of there? The function is discontinuous at each n of 1 by n. Fine. Because if I simply take, if I take n is my 1, so this function becomes my 1 axis. When if I take n is 2, the function is my 1 over 2 here, 1 over 3 and so on. So clearly say the function is discontinuity at each of this one and start from 1, 2 and what is that? It is my infinite set. Fine. Now whether it's a countable or not, how you can prove that? I can take the limit point. What is the limit point of this? 0, which is finite. So once the limit point is finite and it's a bounded, it means it is my Riemann integrable. So f is my Riemann integrable. F is my Riemann integrable. This is a yes, this is a correct statement. Now G, set of the natural numbers, clearly says whether it's a bounded, clearly says this is my not bounded. Fine. So once this is a not bounded, it means this is my not Riemann integrable. So only f is my Riemann integrable, not G. So B is my correct option. Look at that. There is no need to solve it partition or any of thing are there. Okay, your target is to find the G circle F. I already gave you the tips. If you prove that F is my Riemann integrable, G is my continuous, then this is my Riemann integrable. So you can see that G is my continuous. Fine. F is my Riemann integrable. So all these properties satisfied. So this function is a Riemann integrable satisfied. If it is a Riemann, if this is my Riemann integrable, it implies it is also the Lebesgue integrable. But he said not Riemann. Cancel, not necessary measurable, cancel out, because if it's a Riemann integrable, then the measure set of this will be my 0 if and only if. Is a continuous? Not always true, because for this we need a 1 function as well. So the right answer is only A is my correct answer. And you can see these are the questions from the GATE examinations. Okay, F is my bounded, where, okay fine, F is my Riemann integrable if and only if F is continuous. Yes, fine. If it is continuous everywhere apart from the discontinuities P. So what is the set of the discontinuities? F is discontinuities. If I quote S is my set of the discontinuities, then the measure of that set must be 0. So a set of the measure 0 is my here. It's only the finite number of points is not true. You must have a countably finite number of the points. Fine. A countably infinite number of the points. It's a wrong. Countably finite number of the points, or the limit point must be finite. That's why this option, empty set is a cancel. Only B option is my correct option of this problem. Okay, for the positive real number P, Fn is a sequence of the function defined by here. Capital F, F is a Riemann. Okay. Can you find the limit of this function as n approaches infinity? What is that? If I take as n approaches infinity, this becomes a 0. Fine. This function is 0. So it means nothing is there. And this function becomes my here. And clearly say this function is independent of the n. So it means this is my fine. Now what is that? Is this function is continuous? Clearly say this function is my discontinuous. Fine. If function is discontinuous, then what does it means? Fn, the sequence Fn is not converges uniformly. Why? Because it is my not pointwise convergent. If it is not pointwise, then it means it is not uniformly. So Fn converges uniformly is the wrong statement. Fine. Now you can see about that whether it's a Riemann integrable or not. So clearly says your function f is my here. So or in journal I can say this is 1 over x raised to power p in terms of the n is my here. Fine. This is the meaning of this. Clearly says whether the function is my bounded. Is the function is bounded? Clearly says when the function is 1 over n, or when the function is my 0, when x is my 0, this function is my unbounded. Fine. Once the function is my unbounded, it means it is my not Riemann integrable. So this option is also cancelled. Now next one is the improper integral. That will be my next lectures. Okay, but I will tell you how you can solve this problem. Now you have to solve 0 to 1 f of x. F of x is my here. So whenever 0 is the point of discontinuity. Fine. Now this function is convergent if p is less than 1 and divergent if p is my greater than or equal to 1. So clearly says whenever p is less than 1, this is my convergence. So this option is also cancelled. C is my right answer. I will explain the improper integral after this lecture, boundary variation and then improper integral. Also, if I give you one more tips, if my function to be here, fine. Now again, now in this case, infinity is my improper. Infinity is my improper. Then this is my convergent. If my this result will be reverse. Fine. Convergent if greater than 1 and divergent if it is less than or equal to 1. If below is the discontinuity point, then the less than sign is the convergent, otherwise greater. Okay, f is a non-negative Riemann integrable. F is my Riemann integrable. It is already given to you such that this will hold. Okay, very simple tips. Okay, whenever the function is from, say, okay, I can simply say a to infinity fx gx of dx, it will be equal to g of some point, say c, over the domain a to b. Remember, here is a infinity, here is a ab, where c must lies between a comma b. Fine. Now clearly says, you can see the function is my limit is 1 to 2. Now it is my here. So if I compare this function by here, what is my g of x? G of x is my 1 by root x. Fine. So what does it means? What is the g of c? 1 by root c, where c is belongs to my 1 comma 2. Now if I compare this function, what is my g of c? Is my k. So k is my 1 by root c. Now if c belongs to this, what is my root c? Root c is belongs to 1 comma root 2. Then 1 over root this will belong to my 1 over this comma 1. So clearly says the upper limit will be my closed interval 1. But you can see it's not be the 1. It is more than 1. This number is more than 1. This number is less than 1. Only right option is here. Now you can see it's a closed. It is my 1.414 by 2 comma 1. That means 0.707 comma 1. It's a closed interval, but you can see it's a 0.66 comma 1. It's a closed, it's a open. So you can see it satisfied this property. So C is my right answer by using this simple tips of the problem. Okay, look at this another one. F and G are the two functions which are defined here. Then clearly says of this. Look at this function. Is it a bounded function? Because n is my natural number. So if n is natural number, this function is my bounded. Fine. Now you have to prove is a discontinuity. Clearly says this function is my discontinuous at all those points of the 1 by n, where n varies from, where n is my natural number. Fine. You can easily make them. You can see if I take n is 1, so this function is my 1. If I take n is 2, then x will be 1 over 2 and so on, otherwise 0. Fine. So what is that? If limit is there, what is the limit of x approaches half negative? It's a 0. Fine. Which is not equal to f of half. It means discontinuous. So what is that? Now they are infinitely many. So now either you want to prove is a countable, fine, or you can prove that the limit point is my finite. So clearly says what is the limit point of this? Limit point is 0, which is finite. So once the limit point is finite as well as is a bounded, what does it mean? It means f is my Riemann integrable. So f, this is cancelled. Fine. Fine. Now if f is my Riemann integrable, it means f is my Lebesgue integrable. Fine. That is also correct statement. So f is my Lebesgue is correct option. F is Riemann correct statement. Both f and g are okay. Now we can check about the g. Clearly says this is my bounded. Fine. But how many discontinuities are there? It's a discontinuities for all those x in the R, which is uncountable. If it is uncountable, it means g is my not Riemann integrable. Fine. So both f and g are integrable is a cancel. G is a Riemann integrable, cancel. Only correct option is my B is the right answer. Remember, G is my Lebesgue integrable. As I proved that G is not Riemann, as I already told you, Riemann integrable implies here, but converse is not true. Converse only true, not Lebesgue integrable implies not Riemann integrable. Fine. But how you can prove that it is a Lebesgue are there? What is that? If it is a uncountably are there, so G is my Lebesgue integrable but not the Riemann integrable. So the G, that is a B, is the right answer of this problem. Okay, which of the following statements are my correct? Every bounded function is a Riemann integrable. Wrong statement. So many examples are there. If I consider 1 minus 1 for all those rationals, irrational, clearly says this is my bounded but not Riemann. Fine. Or you can consider any of the other example. 0, 1, x is my rational, is irrational, again is a bounded but not Riemann. So every bounded function is irregular. Every bounded function need not be, fine, this is a correct statement. Every constant function is a Riemann integrable. That's true, because every constant function is my continuous function and every continuous function is my Riemann integrable function. Every constant function need not be Riemann integrable is a wrong statement. B and C are my correct answers. Which of the following options? Choose the correct option. Every continuous function is Riemann integrable. Correct statement. If the function is monotonic, then it's a Riemann. That's correct. A bounded function, so it means a bounded plus which has only a finite number of the discontinuities. That means a finite number of discontinuities is integrable is also the correct statement. That's a simple shortcut tips, as I mentioned in the earlier. In the starting of the video, I told you the simple shortcut tricks, which is directly the question of here. Okay, consider the following statement. F is Riemann integrable if and only if. That's a wrong statement. Not the if and only. The statement is if F is continuous, then it is my Riemann integrable, but converse is not true. Okay, again it has a finitely many discontinuity, but we need a bounded as well. So both these statements are my false statement. Both these statements are my false statement is the right answer. It must be the bounded as well, then only this one statement is satisfied, but none of this is my correct statement. Okay, the limit of this and the Riemann integration. Okay, any function f of x dx, you can return this function in terms of here. Fine, where r very strong, say 0 to n minus 1. This you can easily say if your Riemann integrable function. Now you can see limit n approaches infinity. This is a simple formula, but there is no need to think about that. I can simply write this function k varies from 1 to n, 1 over n. I can return like here. Fine. Now I can simply use the integration. I can put k over n is my x, then 1 over x dk is my dx. So 1 over n is my dx. This is my x. What is the limit? When k is equal to 1, it's a 1 over n. As n approaches infinity, it's a 0. When is a n, it is my 1. Fine. So what is that? If you compare, what is my fx? Fx is my x over the domain 0 to 1. So D is my correct answer of the problem. Okay, look at this one. F is my bounded function. Fine. Then it's a Riemann integrable. It's a wrong, because bounded plus we need a discontinuous function having a finite or countably many points. Otherwise the limit point must be 0. So, or we can say it's a 1 minus 1, rational, irrational. So clearly says this function is bounded, but it is not Riemann integrable. First option is cancel. Look at this second option. F is my continuous on this except for the finitely many point. Finitely many point. That's a Riemann integration. That's a correct statement. Fine. No. Yes. No, but we need a bound. Yes, bounded is already given to you. So continuous. That means what is that? It means the function is discontinuous at the finitely many points. That's the correct statement. F is a bounded, F is a Riemann integrable, implies F is continuous. Wrong option, because I already told you F is continuous implies f is Riemann, but converse is not true. You can see the greatest integer. Fine. It is a Riemann integrable function, but it is not continuous function. Fine. F is Riemann integrable implies monotonic function is a wrong option. The result is, if it is a monotonic function, then it is my Riemann integrable, but converse is my not true. So the right answer is only B is my correct option. Okay, look at this another one. So clearly says this function is my bounded. Fine, because it lies between -1 to 1. Now once we prove is bounded, then your target is to prove the function is discontinuous or not. Clearly says this function is my discontinuous. At which point? 1 over r, 1 over r plus 1, and so on, where r varies from this. Or I can written this is in general 1 over r, r is my 1, 2, and so on. You can write it if you want. If I take r is 1, what is the function is? Is my plus 1, when is 1 over 2 x 1. When if I take r is 2, it is my -1, 1 over 3 x. So clearly says this function is my discontinued at half. Similarly, discontinued at 1 over 3 and so on. Now once is a discontinuity, it has infinitely many points. Your target is to prove is either countably or limit point. So what is the limit point of this? Limit point is my 0, which is finite. So once the limit point is 0, finite is also the bounded. It's a Riemann integrable. It's not a Riemann integrable. Cancel. He said f is integrable but not unbounded. It's a cancel option. None of this is cancelled. B is my correct answer. Okay, look at this another one. Clearly says it is a bounded, but this function is discontinuous for all those x in D, which is uncountable. Hence, it is not a Riemann integrable. Again, it's a bounded. Plus, they have the finite values. It's a finite discontinuity points. Fine. So it means this is a Riemann integrable. 0, rational, irrational, p by q, it is my unbounded function because q is my, here is unbounded, it means it is my not Riemann integrable. So this is my correct. Moreover, yes, it's unbounded function. Okay, look at this one. F is a function. You have to find this. Okay, clearly says, is it a Riemann integrable? Clearly say it is not a Riemann integrable because there are infinitely many discontinuous points. So once it's not a Riemann integrable, so the lower and upper are not equal. So do you have any value which are not? Now out of this x and 0, which one will give you the minimum? Which one will give you the maximum? So clearly say this will give you the minimum, this will give you the maximum. So I can find the upper sum corresponding to this one. The domain is 0 to 1. Answer is half. So u, that is upper, this is my is 1 cross, half correct, this correct, upper is 2 cancel. Now you can find this lower x of dx. Sorry, lower is my 0. So the answer is 0. So C is my correct answer of this problem. You can see how many seconds you are needed to solve the problem. A fraction of second are there. Okay, look at this another one. Okay, so f is integrable and so on. Where p, okay, clearly says the function is my bounded. Fine, because it's irrational and here. Okay, is the function is continuous? It's a irrational. Okay, function is continuous at x is equal to 0. Fine. Function is also continuous at all those irrational points, because whatever the irrational are there, answer will always be 0. Now, can the function is continuous at this rational? Look at that. Function is discontinuous at every non-zero rational points. Fine. Clearly says it's a 1 over q, and if I take 1 over 3, then if I take 1 over 4, if I take 1 over 7, if I take p and q such that they are co-prime, or 2 by 7, clearly say this answer will be 1 over 7, 1 over 4, they are not continuous. So discontinuous at every rational points. So what does it means? F is my discontinuous, or you can say F is a continuous except certain points. What are the set is? Number of the points in the set, number of the points in the set which are rational points. So number of the points in the set which are rationals, and we all know what is the measure of this set of rational is my 0. So once a set of rational is 0, what does it means? It only means if F is my Riemann integrable. So F is not Riemann integrable, F is Riemann, all are correct. Now what is the answer is? Now you have to integrate this part. So whenever you want to integrate, you need a function is continuous. Look at that point which is continuous, 0, irrational. What is the function value at irrational and the continuous? Is because this is a discontinuous. Whenever you want to integrate over this Riemann integrable, you always need a continuous function. Continuous function value is my 0. So it means 0 of dx answer is 0. So the answer is, correct answer is D is my right answer of this problem. So this is the way you can solve the Riemann integration question in a very simple manner, provided you must understand this lecture very carefully. We will see the next lecture again with the help of the shortcut tricks on the bounded variation. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.